Hello, everyone. We're going to go over section 1.1, which is going to be the nature of mathematical reasoning. So as an overview, with reasoning that we have here, we say, do you flip a coin every time you need to make a decision? The answer should be no. It becomes very tedious to flip a coin every time you need to make a decision. So instead, we use inductive reasoning or deductive reasoning, which is usually just the reasoning that we already have in our brains. So a lot of time we already do these things, or just now applying it to kind of mathematical, inductive and deductive reasonings here. So we do call inductive reasoning, we can call that induction, and we call deductive reasoning deduction as well. So if you hear either of those terms, that's what we're talking about. So starting off, identifying two types of reasoning, so the induction and deduction. We're going to focus on induction or inductive reasoning first, and then we'll talk about deductive reasoning. So first off, we have inductive reasoning, or induction is the process of reasoning that arrives at a general conclusion based on the observation of specific examples. So inductive reasoning is inducing a result based on specific examples that you have seen. So this leads you to make a conjecture or an educated guess. So a conjecture is educated guess, it's really what it means. But that's what inductive reasoning is going to be. So having these specific examples, you will make an educated guess based on what you've seen in specific examples already. So an example of this would be that if I gave you a surprise quiz every Thursday for the first 4 weeks of class, you would probably guess that there's another surprise quiz on that next Thursday. And you'd probably do some studying, or at least you'd hope you do some studying. So that would be an example of induction or inductive reasoning. So you have these examples, you're given these quizzes every Thursday. So by that 5th Thursday, you're kind of assuming there's probably going to be a quiz today based on these previous examples. So that's more of a descriptive example. We also do have an example here on the side with a mathematical like symbol, or just symbols in general here. So we have these first symbols, we have the first row. So we see they almost kind of look like fish a little bit. So we see that it's the same symbol, but it's being rotated. We can see it's being rotated clockwise in this case. The center is a solid dot, and then it's being rotated. So you see the 4 different types of rotation there before you would go back to the beginning. So in the row below, it's really the same symbols. The only difference is that the dot is not filled in. So we see it's also rotating clockwise. So you would make an assumption on what that last symbol should be. The last symbol in this case, really, it should match the one above it. It just doesn't have the filled in dot. We can see that it's following the same pattern. So we can assume, we can use inductive reasoning to assume that that very last symbol will look just like the one above it, except with a dot in the center that is not filled in. So these are some examples of inductive reasoning. So we'll do an example together. We'll just talk this one out. We're going to use inductive reasoning to guess what the next number in the sequence will be. So we can look at our sequence. We have 1, 4, 2, 5, 3, 6, 4, 7, and 5. You know, you may guess very quickly what that next number is going to be. You may already know. Just as a side note, those 3 underlines, it's just one spot. We're not guessing 3 additional values. It just separated a little bit when I typed that out. So we have 1, 4, 2, 5, 3, 6, 4, 7, 5. And then we want to guess the next number. So the first thing we can do is probably identify a pattern, or try to identify a pattern. So if we start at the beginning, we go from 1 to 4. Well, if I want to go from 1 to 4, that would be adding 3. And then the next number, 4 to 2, the only way to go from 4 to 2 would be to subtract 2. In theory, that could also be by dividing by 2, but let's try out a couple more numbers and see how it works and see if that's true. So now we're going from 2 to 5. So from 2 to 5, we're adding 3 again, and then we go from 5 to 3. Now, if we divide 5 by 2, that would technically be 2.5, and that's not the next number. The next number is 3. So we would assume at that point, okay, it is definitely subtracting 2, not dividing by 2. So we can safely make the assumption in this case. We can check out a couple more numbers, but we make the assumption that it's going to be plus 3 minus 2, and that's going to be our pattern. And we see that this is correct. Between 1 and 4, we add 3. From 4 to 2, we subtract 2. From 2 to 5, we add 3. From 5 to 3, we subtract 2. From 3 to 6, we add 3. From 6 to 4, we subtract 2. From 4 to 7, we add 3. From 7 to 5, we subtract 2. And now we have our very last one. So that very last value, we're seeing that that next pattern should be plus 3. So 5 plus 3 is 8. So the last number in this sequence here should be the number 8. We would add 3 to 5 for our last one. The next number would then be subtracting 2, so that would be 6, and then it would go on, but we're not required to do that. We just wanted one more. So that was an example of using inductive reasoning. So recognizing a pattern and making a conclusion for future values is inductive reasoning. So all right, that was all inductive reasoning. So now we can move on to deductive reasoning. So deductive reasoning or deduction is the process of reasoning that arrives at a conclusion based on previously accepted general statements. So the main difference here with deduction and induction, we said was making a conclusion based on examples, specific examples. Deduction is going from like a rule or a general statement or a fact and making a conclusion based on that fact. So it's based on overall rules, not examples. So an example of this here below, we say that to be considered a full-time student, you would need to be enrolled in 12 or more units. That's a fact. To be a full-time student, you have to be enrolled in 12 or more units. Blanket statement. So if you're told a student is a full-time student, you can conclude in that case that they are enrolled in at least 12 units. That is the requirement to be a full-time student. You need to be enrolled in 12 or more units. So therefore, if a student is full-time, they have to be enrolled in at least 12 units. So that's kind of the difference there between induction and deduction. So induction, for this same example, induction would be more like, I've met, 6 students. They're all in 12 or more units, and they all claim to be full-time. So like, I assume they're full-time students because they're all in 12 or more units. So that's kind of what induction would be versus deduction in this case is, this is the statement, they have to have 12 or more units to be full-time. So if I know that someone's full-time, they have to have 12 units. So we see it's similar information, but presented in different ways. So here's another example. So we'll talk this one through too. So we have L sorority. It requires its members to get a 2.5 GPA or they will be kicked out. So there's your statement, there's your fact. And then we say that L got a 3.2 GPA, so she can conclude ... So we want to make that conclusion for her. So once again here, we have that blanket statement. We have the fact. If you have lower than a 2.5 GPA, you will be kicked out. The assumption is that if you have higher than that, you don't get kicked out. So in this case, if L ended up getting a 3.2 GPA and all that was required was a 2.5, we can assume that she's going to remain a member. She's not getting kicked out. If she had a 2.1 GPA, then that would mean, yes, she is getting kicked out. So deductive reasoning was going from like a fact or a statement and making that conclusion based on your fact or statement. All right, so we've gone over the 2 types of reasoning, inductive and deductive reasonings. So now we're really going to analyze the difference and explain the difference between them. We've done this a little bit already, but we're just going to repeat ourselves. So inductive reasoning begins with specific examples and leads to a conclusion, or general conclusion, your educated guess. So we use inductive reasoning to make conjectures. Remember, conjectures are educated guesses. So we use inductive reasonings to make those conjectures. Deductive reasoning starts with a general principle, a rule, a statement, a conjecture to begin with, and then we draw conclusions about specific examples. So it's kind of just opposite. So we use deductive reasoning to prove conjectures. So proving those principles or proving those rules. We see here we have a picture of the thinker statue. But right below it, we see that inductive means going from specific to general. So going from a specific example and making general conclusions. Deductive would be from going from general conclusions to specific examples. So we see here that it's very similar. It's mostly just opposite. So that's going to be the main difference between inductive and deductive reasonings. So we're going to go ahead and we'll decide whether or not each situation describes inductive or deductive reasoning. So we have two situations here. We're going to figure out which is which. So our first one, part A, we say the last 6 times we played our arch rival in football, we won. So I know we'll win on Saturday. So in this case, we're starting off, first of all, we're numbering, we're saying 6 times. That really means 6 examples. So I'm starting off with my examples and I'm making a conclusion. I'm saying we've won the last 6 times, we're gonna win the 7th time. And first of all, there is no promise that that will happen. So making, in this case, the inductive reasoning that you'll win Saturday is an educated guess, although it may not be correct. So there's no guarantee you'll win a 7th time if you've won 6 times in a row. But in this case, this is inductive reasoning. I have specific examples. I basically have history of this thing being true. I'm going to assume the next will be true or the future will be true. So A is going to be inductive reasoning. So taking those examples and turning it into a conclusion, an educated guess. Then for part B, we have a different situation here. We say there's no mail on holidays, and since tomorrow is Labor Day, I know that my student loan check won't be delivered. So we're starting off by saying there's no mail on holidays. So we're starting with a general statement, a rule kind of thing. So we know for a fact, no mail on holidays. And we're saying tomorrow is Labor Day. Labor Day is a recognized holiday. So tomorrow's a holiday. There's no mail on holidays. Tomorrow is a holiday. So we have 2 facts here. So we're concluding my student loan check will not be delivered. So in this case, we're going from that general conclusion to a specific example. Specifically, I will not be receiving my student loan check. No mail is getting delivered, but specifically me. I'm not getting this thing that I want in the mail because it's a holiday. There's no mail on holidays. So that would be deductive reasoning then in that case. So we see the 2 differences there. Once we can figure out the main differences, it becomes that much easier to kind of figure out which is going to be which. So moving on. We can use inductive reasoning to make conjectures and finding a counterexample to disprove a conjecture. So we're going to kind of set up some like problem-solving skills. So starting off, inductive reasoning cannot tell us for certain that a conjecture or an educated guess is true, just that it is likely to be true. So with that last example of we've won 6 times in a row in our football games, we're obviously going to win the next one. That's an educated guess. There's no guarantee that that is true. It's just likely based on past events. So this means that a really major drawback for inductive reasoning is that you really can't verify every single case. And you're never absolutely positive that a conclusion that you've drawn is true. You just know it's likely to be true based on previous experiences. So that's a very, very big drawback of inductive reasoning. It's great, it's useful, it's just not always going to be maybe that accurate. So it's not easy to prove something is actually true, but it's actually very easy to prove that something is false. You only need one specific example to prove that something is false, and we call that a counterexample. So a counterexample is a specific example that would contradict your conjecture. So again, with the football analogy here, we say that we can't prove that that 7th football game will be a win, but, maybe before the season started, you had like a scrimmage and you lost that. That's kind of a counterexample by saying that, like, well, there's no real guarantee you're going to win the 7th one, especially if you go and lose the 7th game. That's definitely going to be a counterexample. So proving something is true is incredibly difficult, but proving something is false is incredibly easy. You just need one counterexample. One is enough. More is always great, but one is enough. One is all you really need. So as a warning though to this, one counterexample is enough to prove a conjecture is false, but one positive answer is never going to be enough to prove a conjecture is true. Really, it's very like a little bit more on the rare side to prove that something is actually true. It's a lot harder. You need like very concrete examples. You maybe even need like theoretical examples to prove that something is true. So one positive result is not enough to prove that something is true, but only one false one is good to prove it wrong. So just remember that as a warning. Very hard to prove something's true, very easy to prove something is false. So as another example, we're just going to find a counterexample to disprove the conjecture, the educated guess, that the name of every month in English contains a letter Y or R. So in this case, we just need to find one example where this isn't true. The educated guess is someone saying every month in the English language contains a letter Y or R. You just need one example where it's not true. So we'll go through the months and we'll decide which one is and is not true, or if it is or is not true. So starting off with January, you heard it in the word, ends with a Y. It's got like 2 R's in it. So January, that's not going to be it. It has 1 R. So next one, February. Once again, you heard it. There's a Y, there's an R, so February definitely doesn't count still. Then you have March. There's no Y, but there is an R in March, so that doesn't count either. Next one is April, so doesn't have a Y, but once again, it does have an R, so April does not count either. Your next one would be May, ends in a Y, it doesn't have an R, but does end in a Y, so it's also not a counterexample. After May, we have June. Yeah, so June does not have an R and it doesn't have a Y. So there you go. There's your one counterexample. Not every month contains a letter Y or R. June doesn't have an R or Y. So there's one counterexample. If you were doing this problem on your homework or an exam or anything, that would basically be where you stopped. Hey, I found one. There you go. Done. For the purpose of our example, we're going to keep going just to kind of figure out all the different counterexamples. So we said June was a good counterexample, didn't have Y or R. Our next one would be July, Y at the end, so that one's not good either. Then you have August. August does not have an R or a Y. So August would also be a great counterexample. So June and August would be great ones at this point. So we'll keep going. After that, we have September, ends with an R, so that's not good. October, ends in an R. November, ends in an R. December, ends in an R. So the only 2 counterexamples we would have in this case would be June or August. But you only need to list one. So whichever one you come up with first, that would be the one that you could list. So there we go, June or August. And that wraps up section 1.1. So in section 1.1, we learned about the differences between inductive versus deductive reasonings. We looked at using inductive reasoning to make conjectures or educated guesses, and then finding counterexamples to disprove conjectures, educated guesses. So there we go. That wraps up section 1.1, and I'll see you all again in 1.2.